Hi, everyone. So, as you already heard, I had a huge title for this presentation, but if I'm simplifying things, I'm going to talk to you about how to get cost-effective models in production. My name is Irma. I'm a data scientist at Wix, and in my time at Wix, I deployed several models in production in several areas. And in each one of them, as much as everyone knows of the ML lifecycle, we are always driven to get to deployment as fast as and with the best performance we can. But what happens next? We neglect to take into consideration the next part. But does it really end there? Keeping models in production is a really hard job. And it's a hard job because it costs a lot. And when I say cost, I refer to several aspects. First of all is money. Data generation and data storage is a huge amount of money, and we really want to reduce it. Second is data drift. When you are a company like Wix that is always evolving and its products always changing, we are prone to a lot of data drifts in our features. And last, maintenance. The number of times I get this kind of email that someone deprecated a table I'm using or a feature I'm using is countless. So how can we deal with that? I'm going to show you a simple technique. By applying small steps in the model exploration part, we will get to cost-effective models once we deployed our models. And when I'm talking about cost-effective models, think about it, which data do you need to get to cost-effective models? We want in one hand the cost, the cumulative cost of having each feature family in our model, and we want its contribution. Having these two factors will help us get a right decision, right? So let's imagine that I gave you a magical table, that someone gave me this table. And we understand by adding each one of the feature family, we understand how much it's going to add to the cost and how much it's going to add to the contribution. And having this kind of a table, we can have this decision, the easy ones that are like adding only cost without any contribution, and the hard ones that we really need to have a hard decision whether or not we want to use this feature family. So I will take you for the steps to get to this kind of a table in a simple way in your models. But first, let's take a use case. We at Wix were asked to provide a continuous completion score to our websites, okay, reflecting the readiness of Wix users. And you can understand why Wix needs this kind of KPI. We want to help our users reach their goals. And now let's go over the simple steps that I mentioned. First, we want to define our cost function. In order to define our cost function, we need to take into consideration two aspects. One, what are the criteria we want to use in our cost function? And as you can see here, I chose money, data drift, and maintenance, like you saw before. You can use any other metric that your company sees fit. And second, the weights we want to give each one of our criteria. Okay? I chose 50% for the money, 30% for the data drift, and 20% for maintenance. Again, this suits Wix in this use case. Okay? Next, it's going to be mapping our features to feature families, but keeping in mind the criteria we said before. Okay? For instance, third-party DB, we know that it's going to cost more money and it's prone to more maintenance later on. Okay? And if you have several features in the same business logic, but you know that the cost will be different, so let's separate it to two different feature families. Okay? This should serve our need to calculate the cost later on. Okay, next step will be, first I want to, from now on I will call each feature family with a letter just to simplify things later on. And the next step, we are going to actually calculate the cost for each feature family. So for each feature family, we know the criteria we defined before, we know the levels of cost we want to give each feature family, And eventually, using the formula, we are going to calculate the final cost for each feature family separately. Great. Next, we want to calculate the contribution. Okay, we had the cost, now we want to understand the contribution for each feature family. Contribution in this use case, as I said, it's a continuous completion score, is RMSE. We want to lower down the RMSE as much as we can. So for each feature family separately, we are going to train our model and calculate the RMSE for each one of them separately. And once we have these two factors, we're going to rank our feature family first by cost, because we want to take the less costly feature family into our models. And second, if we have the same cost, we will gonna rank it by the contribution. And eventually we're going to get the order of the feature families we want to add to our model, okay? But I showed you cumulative, right? So now we are going to calculate the cumulative cost and contribution. Let's start with the cumulative cost. Cumulative cost is actually easy. Adding each feature family is gonna add the cost, adding cost for each feature family. And cumulative contribution is taking all features, for example, from A and B, retraining and calculating the RMSE. This is why we're talking about feature families and not each feature by itself. This could be an expensive part once we are trying to retrain every time, but if we have a small number of feature families and we know their cost, so it could be a simple process. Great, so I promised you we get to this table. We have for each addition feature family, we have the cumulative cost and the cumulative RMSE, which is the contribution. And now we are only left by doing the decisions. You can see here that the contribution is 0, but it costs a lot to use C as a feature family. And in the second part, you see now there is a decision to make. But either way, we will know what is the nature of the models we're getting into production. We will know in advance that we took the chance. It's going to cost us more, but we want to improve the performance. Great, we applied it at Wix in this use case I showed you, and we managed to reduce the cost, the money that we are generating in our data set in 30% without hurting the performance at all. And we also minimize the maintenance we need for this model. And I know it because I'm maintaining this model. The main takeaways I want you to take from this lecture. Thinking about the day after production is crucial. Ignoring the problem will not solve it. And I want you to take the simple method I showed you, and if I'm summarizing it to 3 main steps, is ranking by cost and contribution, calculating the cumulative cost and contribution, and then the decision-making part. Okay, it's also really easy to imply, so you can do it even retrospectively. Thank you very much for listening.